You would expect lava to be the first thing that kills you on Io. It wouldn't. Not even close. Io looks like the obvious nightmare moon. It's the most volcanically active world in the solar system, marked by active volcanoes, sulfur dioxide plumes, and glowing hotspots. Jupiter hangs over it like a god-sized threat, and the whole place looks less like a moon and more like a planet-sized industrial accident. So the obvious answer seems easy. You land on Io, and sooner or later, lava gets you. But Io is cruel in a more interesting way. It would kill you in the wrong order. The first thing to understand is that Io does have an atmosphere, but calling it helpful would be ridiculous. It's extremely thin, and it's made mostly of sulfur dioxide vented by volcanic activity. In other words, you would not be standing in a breathable alien sky. You'd be standing in something much closer to a toxic near vacuum. So before the volcanoes become your problem, your own body does. No breathable oxygen, almost no useful pressure, and sulfur compounds where air is supposed to be. That's the first twist of Io. The world looks like it wants to kill you with fire, but it starts with the atmosphere. And Io's atmosphere is so unstable that when the moon passes into Jupiter's shadow, much of its sulfur dioxide freezes onto the surface, causing the atmosphere to partially collapse before sunlight builds it back up again. That first problem is the easiest one to solve. A sealed suit, pressure, life support. But even then, you're still not safe. This is where Io gets worse. Io sits deep inside Jupiter's magnetosphere, one of the harshest radiation environments in the solar system. Jupiter's magnetic field traps swarms of charged particles, accelerates them to very high energies, and bombards the innermost moons. Io is not just sitting near Jupiter. As Jupiter rotates, its magnetic field strips material from Io, ionizes it, and helps form the dense plasma torus around the moon's orbit. A life support suit would not solve that problem, because a dangerous radiation dose could still damage tissue, affect the central nervous system, and eventually leave you too sick to function. So once you've solved the problem of breathing, Io reveals the next threat: radiation. The space around the moon is hostile long before the surface does anything dramatic. And only then do we get to the thing everybody expected first: the volcanoes. Io's volcanism is powered by tidal heating. Jupiter's gravity pulls on the moon constantly, while Europa and Ganymede help keep Io's orbit slightly stretched instead of perfectly circular. That means Io is flexed over and over again, and all that internal deformation turns into heat. The result is extreme. Volcanoes on Io can launch sulfur dioxide plumes hundreds of kilometers above the surface, and some eruptions may involve lava reaching around 1,700 Kelvin, or even higher, hot enough to suggest very high-temperature silicate volcanism. So if you somehow survive the atmosphere and the radiation, this is the part that can still finish you: erupting vents, falling plume deposits, and a surface that is constantly being reshaped by heat and fresh volcanic material. Io doesn't just have eruptions. Its volcanic resurfacing is so intense that impact craters are essentially erased from the surface. This moon is not quietly cooling. It is constantly rewriting itself. And that's the real payoff. Io matters not just because it's deadly, but because it reveals a planetary process at full volume. It is a natural laboratory for tidal heating, showing how gravity can pump energy into a world until geology becomes extreme. Study Io, and you learn something bigger than survival trivia. You learn how worlds evolve under stress, how tidal heat is generated and lost inside planetary bodies, and why some moons and planets can stay active long after you'd expect them to go cold. So yes, Io would absolutely kill you. But the reason this moon is unforgettable is that it wouldn't do it in the order your intuition expects. First, the thin, toxic atmosphere, then Jupiter's radiation, and only after that, the fire. Like the video, subscribe for more space stories like this, and watch Why So Many Moons Look Like Potatoes or Ravioli next. It's a perfect follow-up to this one.